This is Mrs. Huntley. We are in Module 7, the real number system. And on last night's homework video, I asked you to be working on pages 47 and 48, and I told you we would go over in class. Well, at the time that I made that request, I didn't know that I wasn't going to be at school and that you would have a sub. So what I decided to do is record a video going over the problems that I asked you to do. Now, you should have already tried to work the problem, so how this video is going to differ from most videos is I'm going to go through and give strictly the answers, and you can be checking your work. It's kind of like a video answer key, checking your work. If you're correct, if everything's good, you're fine to stop watching the video and move on to the classwork for that day. If you had some questions or some problems that you got incorrect, what I'd like you to do is continue watching the video so that you can, or fast forward to the problem that you got correct. So you got the last one incorrect or something like that, and you wanted to just check that one, you can go toward the end of the video just to see that problem or see whichever problems you might have had an issue with. So let's get going. Open your packet to page 47. And the answer to number 4 is the square root of 15. Number 5, the answer would be A, 14.1. Number 6, you know what? I just glanced at the directions. It says which two integers, and I answered with which two perfect squares would it fall between. So 90, the square root of 90 falls between the square root of 81 and 100, which of course is between 9 and 10. And then the square root of 175 is between the square root of 169 and the square root of 196, which 169 would be 13 and 14. So let me put in the 13 and the 14. And then the negative square root of 12 is between the negative square root of 9, which is negative 3, and the negative square root of 16, which is negative 4. So whether you answered with the square roots or the integers, I have both answers there. Number 7, Rebecca bought a square table for her kitchen. The area of the table surface is 65 feet squared was the approximate side length of the square table, and I said approximately 8.06 feet. Next page, A, square root of 47 would be E. Square root of 27 is D, and the square root of 11 is A. And then number 2, I said between 3 and 4, and my decimal estimate is 3.57. Number 3, between negative 12 and negative 13, and my decimal estimate is negative 12.24. Number 4, Miranda brought a square frame, area of 30 square inches. What's the side length? Approximately 5.45 repeating. I guess I should say 5 and 45/100ths repeating. Number 5, about Tristan's garden, and you notice that 64 is a perfect square, so you can get each side length, and then you have to multiply it by 4 for your perimeter, so that would be 32 feet. Number 6, the square root of 90, the best estimate is 9.4, or again, 9 and 4/10. Number 7, which of the following statements is not true? And that would be C. The square root of 12 is between 4 and 5. So again, if you got them all correct, you are fine to stop watching the video right now and move on to page 51. 51 is a couple of pages away. We're going to skip that one for now. We've got a note page. So 51 looks like this. And what I want you to do on this one is give me a decimal estimate. So you're doing a decimal estimate. And round to 2 decimal places. When necessary. Okay, so let's do one together. The square root of 8. So our first step, you guys should have this in your notes. Our first step is to find the two perfect squares that the square root of 8 falls between. And that would, of course, be between the square root of 4 and the square root of 9. So it's going to be, my answer is going to be approximated, and it's going to be 2 and some fraction, because the square root of 4 is 2, and the square root of 9 is 3, so we know it's going to be between 2 and 3, so it'll be greater than 2, but less than 3. Now to figure out the fraction, the denominator take the difference of the two perfect squares. So 9 minus 4 is 5. That's my denominator. My numerator, I'm going to change colors really quick. The square that you're looking for, 8, minus the lower perfect square. So that's going to be 4. So the fractional estimate is going to be about 2 4/5. And now we're going to take that 4/5 and turn it into a decimal, just like we learned to do in a previous lesson. So that's 4 divided by 5. 5 can't go into 4, so I add my decimal. 4, I can add a 0 here. I'm going to ignore this decimal for a moment. How many times does 5 go into 40? And that would be 8 times. 8 times 5 is 40, so there's no remainder. So I can say that 2 4/5 is an estimate, which is equal to the decimal estimate of 5 8/10. Okay, so that's how I would like to see each one of these solved, is you're showing the steps between what two perfect squares, figuring out the fraction, converting that fraction into a decimal. So I did the first one for you. You've got 7 more to do. Again, if you did not get all of the questions right on the independent work that I asked you to be working on, I would like you to come back and I will go through each problem in more detail. Okay, so problem number 4. Those of you, again, that got this all right, you can stop watching the video at this point. Problem number 4. To know where the square root, where a is, what I'm going to do is put in the perfect squares. So 3 is equivalent to the square root of 9, and 4 is equivalent to the square root of 16. So a is right next to the square root of 16. The one that makes the most sense out of all of the possibilities is indeed C at the square root of 15. So number 5, which of the following would be the best estimate for the square root of 198? This is what I just demonstrated to you. So the square root of 198 is between the two perfect squares of 196 and 225. So it's between the perfect squares of 196 and the perfect square of 225. So I know that my answer is going to be between 14 and 15. So it's going to be 14 and some decimal, some fraction. So I'm going to write that down here, 14 and some fraction. I don't know what fraction yet. The way I figure out my denominator is going to be 225 minus 196. 225 minus 196 is going to be 29. So my denominator is 29. To figure out the numerator, the number I'm looking for, 198, minus the lower perfect square, 196, and that would be 2. So my numerator is 2. Now I need to convert that fraction into a decimal. I'm going to do my long division. 2 goes inside, 29 goes outside. Now obviously 29 can't fit into 2, so I'm going to add my decimal. 29 can't fit into 20, so I'm going to add another 0. 29 can fit into 200. 29 is super close to 30, so I'm going to say 33 would go into 20 6 times. That would be 18, so I'm going to guess 6 right here. I'm just saying that out loud because it's my thought process, and I want you to know why I pick the numbers that I pick. Okay, so 6 times 9 is 54. I write down my 4 and carry my 5. 6 times 2 is 12, plus 5 would be 17. 200 minus 174 is going to be 26. I could put another 0 and bring it down, but I actually have enough information to solve my answer because I've gone to 2 decimal places here, and because this is greater than 5, this decimal place, is going to be bumped up by 1. So my answer is approximately, I guess I should have put those in there, approximately 14.1 rounded. Out of all of the choices that are here, this one is the one that makes the most sense. Okay. Number 6, I kind of walked through because I had answered it incorrectly to begin with, but that's, finding the perfect squares that it would fall between and then figuring out what the square root is the way that you would solve that one. Number 7, Rebecca bought a square table for her kitchen. So I'm going to draw my square table. and it's 65 feet squared. So all of my sides are the same, and the way I find an area is side times side. So there'd be side squared equals 65, and of course take the square root of both sides. Square root of 65 is not a perfect square. It's going to fall between the perfect squares of 64 and the perfect square of 81. So it's going to be 8 and some fraction to figure out the denominator. 81 minus 64, the difference in the two perfect squares, and that's going to be 17. To figure out the numerator, the number I'm looking for minus the lower perfect square. So it's about 8 and 1/17, which when I do that long division, 1 divided by 17, of course it can't go in there. Doesn't go in there either. 17 going into 100. I'm going to think like 17 is close to 20, and 20 would go into 100 5 times, so I'm going to guess 5 and see if it works. 5 times 7 is 35. Put down the 5, carry the 3. 5 times 1 is 5, plus 3 is 8. So 85 going to 100, the difference there is 15. Bring down another 0. So I see if my 5 stays a 5. Let me get rid of that. There we go. And then, let's see, 17 going into 150. Thinking about 20 again. 20 going into 150. I'm going to guess 8 here. 8 times 7 is 56. 8 times 1 is 8, plus 5 is going to be 13. 150 minus 36, okay, that's 14, so that worked. All right, so that means this 5 is going to get bumped up 1, so that's why I came up with about 8.06. Okay, please do the summary, and what I would expect to see in the summary is how, summarize the process in your own words about how you go about estimating the approximate location of a non-perfect square. Moving right along. This next one, the number line one, I love these problems. What I do to solve them, I don't find them that difficult, but what I always do to solve them before I start trying to figure out where the dots are is I put in the perfect squares. So 3 is the square root of 9, 4 is the square root of 16, 5 is the square root of 25, square root of 36 is 6, square root of 49 is 7, square root of 64 is 8. So now it's easy to see. So looking for the square root of 47, I'm going to look, it's greater than 36, it's less than 49. The only one that's in there is E, so that's kind of easy. Square root of 27, it's going to be between 16 and 25, and again, there was only one in, hang on a second, I'm backward. Square root of 27 is going to be greater than the square root of 25, less than the square root of 36, it's going to be close to 25, and D is my only option. Square root of 11, okay, it's going to be between 9 and 16. Now there's two options there. So what I have to determine is square root of 11 is closer to which one, the square root of 9 or the square root of 16. So I could do a quick difference, 16 minus 9, and see what that is. And that, of course, is going to be 7. And then what I'm looking for, 11 minus 9, that's going to be 2. So 2/7, that's going to be this first one. This one looks like it's more like, I don't know, 8/7 or something for B. So 2/7 would be A, about. Okay, number 2 says use the number line. Estimate the value of the square root of 13 by plotting it on a number line. So what you want to do is figure out the two perfect squares again. Square root of 9 and the square root of 16 is where the square root of 13 is going to fall between. So it's going to be between 3 and 4. So where on this number line? When we're doing our differences, so when I'm taking 16 and I'm subtracting 9 and I'm getting 7, that means there's 7 square roots. 3, 4, 5, 6, 7 on the number line somewhere between 3 and 4. Now they should be evenly placed. I just kind of was winging it here. And where would the square root of 13 fall? That's going to be 13 minus 9, which is 4. So it's going to be 3 and 4/7. So it's 1, 2, 3, 4. You know what? I'm going to even these out just because you're watching this because you got confused on it, and I don't want to mess that up anymore. So here's about the halfway point. So if I need 7 spots, 3, 4, 5, 6, 7. That's a little bit better. So if I'm at 4/7, it's going to be 1, 2, 3, 4. About this one, this would be the square root of 4/7, or 3 and I can't speak anymore. Square root of 13 would fall here. That's what I'm trying to say, just not saying it well. Okay, so about 3 and 4/7, and then I take that 4/7 and I'm going to convert it into a decimal. So it's going to be 4 divided by 7. 7 can't go into 4, so add your decimal. 7 goes into 40 5 times, and that's going to be 35. 7 goes into 50 7 times, and that's 49. 7 goes into 10 1 time, so I know I don't round that up, so it'll just be about 3.57. Now when you're finding a negative square root, like number 3, it's the same thing, it's just the number line is going to be backward. So the square root of 144, the lower perfect square, is going to be on the right. The square root of 169, which is the absolute value is higher, but the number line is going in the opposite direction. So this is 12, and this is negative 13. And again, we're going to find our difference the same way. Take the larger absolute value, which is your distance away from 0, 169 minus 144. How many spots on the number line is that? That would be 25. So I know it's going to be about 12 and some fraction. The denominator is 25. And to find the numerator, number I'm looking for, 150 minus 144. And that difference is 6. So it's about 12 and 6/25. I'm going to do my long division. 6 divided by 25 does not go in, so I got to add a 0. 20, oops, not a 0 up there. What am I doing? Confusing myself. Okay, so 25 goes into 60. That would be 2 times. That's 50 with 10 left over. I'm sorry, with 1 left over. Bring down a 0. It's 10. It doesn't go in. I am so messing up right now. It is indeed 10, not 1. I'm losing it. I need more coffee. Okay, so 25 goes into 100 4 times, and that's how I got my answer, about 12 and 24/100. I hope I didn't just confuse you there. I just got myself a little bit messed up while I was trying to do this. Number 4, Miranda brought a square frame with an area of 30 square inches. Drawing my picture. This is 30 inches squared. So again, my side lengths are all the same. So x squared equals 30. Take the square root of both sides to figure out what side length is. And again, it is not a perfect square. It falls between the perfect squares of 25 and 36. So it's going to be 5 and some fraction. To figure out the fraction, 36 minus 25. My denominator is going to be 11. And my numerator, what am I looking for? 30 minus 25 is going to be 5. So 5 and 5/11. Now I'm going to change the 5/11 into my fraction, or I'm sorry, into my decimal. It is already a fraction. So 5 divided by 11. 5 does not, I'm sorry, 11 does not go into 5 evenly or at all. Got to add a 0. Ignore that decimal just for a moment. So 11 going into 50, that's going to be 4 times, and that's 44. Subtract those out. There's 6 left over. Bring down another 0. 11 goes into 60. That'll be 5 times. That's 55. What's left over is 5, and I can see my loop right here because this number and this number are the same, so it's just going to be 4, 5, 4, 5, 4, 5, 4, 5. It's going to be a loop that goes on. That's why I'm putting that bar over my answer, 5.45 repeating. Okay, Tristan is building a square garden in his backyard. I can draw my garden again. I want to switch back to blue, sorry. Drawing my garden, and it is 64 feet squared. Hopefully you recognize that 64 is a perfect square, so each side length is 8. You take the square root. The perimeter is the distance around, so 8 plus 8 plus 8 plus 8, or 8 times 4, which is exactly 32. So it's exactly 32 feet in perimeter. Remember, the perimeter is the distance around. It's the rim of the shape. Okay, square root of 90 is not a perfect square. So again, I have to estimate it between what two perfect squares does the square root of 90 fall? And that would be between the perfect square of 81 and the perfect square of 100. So I know it's going to be 9 and some fraction. To figure out the fraction, do 100 minus 81. 100 minus 81 is 19. That's my denominator. To figure out the numerator, take the number I'm looking for, 90, minus the lower perfect square, 81, and my numerator here is going to be 9. Changing 9/19 into a decimal, 9 divided by 19. 19 can't go into 9, so I need to add a decimal here. 19 can go into 90. Again, 19 is close to 20. So 20, 40, 60, 80. I'm going to go with 4 and see how that works for me. 4 times 19 is 76. 90 minus 76 is 14. Bring down another 0. Again, 20, 40, 60, 80, 100, 120, 140. So we're looking at 7. Okay. So it'd be about, if I was estimating it to 2 decimal places, it'd be about 9.5 if I was rounding up. But 9.5 is not one of the options. So the option that it's closest to is the 9.4, but a more accurate estimation would be 9.47. Alrighty, and the last one, which one is not true? The square root of 112, it's saying is between 10 and 11. Well, let's see, the square root of 10 is the square root of, the square root, I'm sorry, is between 10 and 11. 10, the square root of 100 is 10, the square root of 121 is 11, and 112 does not fall, or does fall, we're looking for one that's not true, does fall within that range. Okay, the square root of 13 is 169, square root of 14 is 196. I remember those because they're kind of opposite. Square root of 180 falls between those, so that one is also true. So we've got 2 true so far. Square root of 12, they're saying is between 4 and 5. Let's see, square root of 16, square root of 25. 12 does not fall between those two. So those two are false. I am going to go ahead and check the last one just to make sure we don't have 2 that are not true. Let's see, the square root of 5 is between the square root of 2 and 3. That would be the it's between 2 and 3, which is the square root of 4 and the square root of 9, and that is again true. So there's only one false statement here. So again, hopefully guys, you got these all correct and you didn't have to watch, whoops, and you didn't have to watch the entire video. But if you didn't get them all correct and you did have to watch the entire video, then I hope that this was very helpful for you. Have a great day, and I'll see you when I get back to school.